without further ado, let's kick the third edition off by welcoming Ben Shneiderman. Thanks a lot, Ben, for being here.
Hello, thank you, Ujwal Gadaraju, for organizing this in the University of Delft. I'm very pleased to be here and talk about a topic I feel passionately about. And I'm coming to you from beautiful Vancouver, where today it's a little cloudy, but the picture behind you shows you the sunny day, the snow on the mountains. So that's my story. And thanks for mentioning the book, which is available now from Oxford University and elsewhere. And I'm pleased that Ujwal has ordered a group of copies. But for others who are tuning in, there is a discount promotion. I should put it in the chat. I'll just do that in a second. Promotion code ASPROM, not typing, ASPROMP8 for Oxford. I'm pleased that Oxford has published the book at a very reasonable price because they believe there is a wide audience for this. And indeed, that's been very satisfying to see that. So let me go straight to the slides and share screen. And there we go. Okay, so that's the story. And I represent the University of Maryland and the Human Computer Interaction Lab. So that's it. And I'm always proud to wave the flag of the Human Computer Interaction Lab, this interdisciplinary community, which is now on its 9th director, almost 40 years going. And excuse me, collaboration between computer science and the College of Information Studies and other groups around campus, including the wonderfully titled Maryland Institute for Technology and the Humanities, MITH. The website has 1,000 tech reports, 200 project reports, and lots of videos. So you can take a look at the work that's going on there. I hope some of you know me from the book, Designing the User Interface, now in 6th edition, requiring 5 authors to tell the remarkable story of the growth and impact of the modest-sized community of people in the human-computer interaction world, and how the devices we have, from the cell phones in your pockets to e-commerce and social media, have been real payoffs from what this community has done. On the other hand, there are downsides and dangers and problems of misinformation and manipulation and bias and unfairness. And so there are continuing challenges that we have to face in putting this technology to work in an effective way. Today's talk, though, shifts to my new theme about human-centered AI. And maybe the central notion here is to say, why are we doing this? And it's not because we think the technology is cool, which we do, but it's because we believe we can build a better world. And maybe the best guide for that is the United Nations Sustainable Development Goals. The 17 goals put out by the UN are backed by 169 metrics. And the plan goes from 2015 to 2030. And so as you think about your work, what we want for human-centered AI is to improve human well-being. And the UN Sustainable Development Goals give us some of the clues. But the focus here today will be on how we can design. That's the Delft strength about designing at scale. So that's what attracted me here also. But how can we design this technology so that indeed it does amplify, augment, empower, and enhance people? Those are old phrases, but I bring them together to reiterate their importance in our time. And we'll see how we return to that as a driving vision for making technology that truly serves human needs. That's what we're after. So there's 3 parts to this talk. The first is the Hci Framework, And then we'll talk about the design metaphors. And third will be the governance structures. But the Hci framework is a new way of thinking of people working together and putting them into groups so they can collaborate or working individually, supported by technology. That's the vision. It's not that we're, we'll just say we want to help people work together in much more effective ways and play together, relate to each other, build relationships, etc. So I take you back in revisioning the goals of computing. In the first edition of my book, I had a chapter called Balancing Automation and Human Control. Balancing automation and human control. And I had bought into the notion of MIT professor Tom Sheridan about levels of automation. He had outlined how you would go from zero automation, full human control, to level 10, which was full computer control and computer automation. So I represent that as a one-dimensional scale. He had 10 steps along the way. But it required designers to think about what degree of automation they wanted to have. And the implicit assumption, which came to bother me over time, was that this was a zero-sum game. That if you increased computer automation, you necessarily reduced human control. And I was really troubled by that. And so over the years, I began to think about a new way to represent the idea. And the chapter in that book, in later editions, became ensuring human control while increasing automation. And when I first wrote that, it seemed like an admirable goal, but I wasn't even quite sure what I meant. And I struggled to define it. And over the years, I came to represent it this way, that there were actually two dimensions, that there was human control was one dimension and computer automation was another. And the goal would be to have high levels of human control and high levels of automation. Now you may say, how can you do that? And that's what this talk is about. And the way to think about it is to decompose the fine structure of design so that you look at which features in an interface or a task require human control and which features are better done by computer automation. So the things that computers can automate for you, go for it. Give me high levels of automation. But the things that I want to control, give me high levels of control for those. And so the way I represent it is a two-dimensional matrix. And the high levels of computer control are on the lower right here. And we think of the fully autonomous pacemaker or airbag. Pacemaker represents an example of the places where computer control is needed because it's isolated, it's remote, pacemaker is inside your body. It has to work and regulate your heartbeat. And an airbag is inside a car, and it has to operate in 200 milliseconds. So the rapid pace and the difficulty of arranging control were the defining features of when you really wanted computer control. We'll see how even this notion has begun to change over time. But by thinking this way, open the door to clarify that there are places where human control, human mastery is paramount. And so riding your bicycle, playing your piano, or being a parent are places where you want control. You want to do it. You want a sense of mastery. You want to be creative. You want to do your thing. And so there's a place where high human autonomy, human control is a virtue. But the space for us as designers that we're looking to is the upper right-hand corner, what I would call reliable, safe, and trustworthy designs. And two simple examples are the elevators we ride, where there's a high degree of automation, a lot of machine learning in modern elevator systems in large buildings, but you're in control of what you want. You walk up to the elevator area, you press the button, the light goes on, and it shows you the elevator will be arriving soon. You go to the door, it opens, you step inside, you press 6th floor, The door closes and you go first, second, third, fourth, fifth, and sixth floor. The door's open. You got what you wanted. Okay, you're in control. Yet there was a lot of AI, machine learning, a lot of safety checks, triple backups, and so on. My favorite example is the digital camera in your cell phone, in your pocket, which is rather amazing in that it has a high degree of automation and machine learning to arrange the exposure, the focus, take care of color balance, make sure the sky is blue, and reduce hand jitter. And yet at the same time, you're in control of the creative aspects that matter to you. You point the camera where you want to, you zoom as much as you want and make your composition, and then you choose the moment when you click for your decisive moments. And that's the virtue of this combination of dual features that are reliable, safe, and trustworthy. You get a preview of what the photo will look like when you click. It's your photo, your creative moment. This diagram also shows there are two dangers on the periphery. The excessive automation on the far right reminds us that there are real dangers in putting up too much automation, too much autonomy, maybe best exemplified by the twin crashes of the Boeing 737 MAX. A complicated story, but the part of it that I'd like to focus on is the fact that there was an autonomous system which took over control of the aircraft without informing the pilots. The pilots were not told of the existence of the MCAS system, which pointed the nose down because of an erroneous sensor, and so led to these two disastrous crashes. It was the belief by the designers that they could make such perfect autonomy that there was no need to let the pilots know of this existence. They took control away from the pilots. Yes, it would have been possible for them to shut it off, but they didn't know that it was engaged. And so that's the kind of excessive automation, and we see that in other circumstances. There's also dangers of excessive human control. And so the self-cleaning ovens that are part of a lot of modern designs of ovens, if the temperature is above 600 degrees Fahrenheit, then the doors become locked. You can't open it because the danger of opening it is just, is potentially deadly, but harmful at least. And so there are lots of ways where excessive human control can be a problem. And human factors design has long engaged with understanding the limits of human control, maybe imperfectly, but that's where we have to go. So the design space is much richer than a one-dimensional one, which says, oh, let's go. Computer automation is the full goal. There are many, many goals, and there are limitations as well. Let me give you another couple of examples of how this plays out. So in medical care, patient control of pain medication goes back to, let's say, the World War II idea of a morphine drip bag, where there was no automation and no human control. The drip bag would drip morphine, and this could relieve the pain, but maybe there wasn't enough morphine, or maybe there was too much, and the patients would die because of excessive morphine. So you can introduce an automatic dispenser, which puts computer control by measuring heartbeat and breathing rates, and then ensures that you don't overdose the patient, but you don't deal with the problem of underdosing. So patient-guided dispensers became a natural approach where the patient got a trigger and they could request more morphine. However, there was a limit to the number of requests they could make per hour, the number of times they could squeeze, and so they prevented excessive human control. Nice design. Where we're going now to the reliable, safe, and trustworthy is patient-guided but clinician monitored. So a hospital control center may monitor 50 of these devices, collect the data, and improve the algorithms for dispensing morphine for different classes of patients. And so we get to a more nuanced, thoughtful approach, which has a much more sophisticated design to it. Right, one more example would be wheelchairs. The old-fashioned wheelchairs were heavy push chairs, that wooden ones that required a caretaker to push around. No automation, required extra help. And robotic ones would wheel the patient around from one place to another, possibly. But we saw the rise of lightweight, hand-powered, user-guided ones, so that we now saw the creative appearance of wheelchair races, wheelchair basketball, and so on. And the direction for that is motorized, joystick-controlled, teleoperated, programmable, and a rich set of things where a control center in a city may monitor thousands of wheelchairs and then learn from the, make algorithmic changes that improve the wheelchair for others, and even collect data about which streets in the city had bumps on them and had potholes that needed to be fixed. So this kind of rich data collection from a control center becomes a way of making more effective designs. All right, so this was first strategy of ways of thinking fresh about the ideas of human control and automation. The second part of this talk is about the design metaphors. And I became increasingly aware that the metaphors and the language, the terminology that was being used was often misleading. And so I began to read and think about this, and I build on the commentaries from, for example, Margaret Bowden. Robots are simply not people. And remembering that computers are different from people. Humans, not robots, are responsible agents, says Joanna Bryson. And those became important foundations for me. And the three philosophies that emerged, maybe three ideas, we'll call them: the responsibility, only humans are liable legally and morally. That changes the game dramatically for designers. And so, robots need to have a sign on them that says, if this robot fails, it's your fault, and you need to be responsible and care for it. So if you're responsible, then you want to know what the robot's doing, you want to know what it's going to do, and you want to be able to stop it from doing it. So comprehensible, predictable, and controllable became the governing force to guarantee responsibility. There's more to say about that, but that's the starting point. The second principle was that computers are really special. They're wonderful. I want to put great computers to work to help people do what they need to do. And so there are distinctive capabilities of computers that we want to make sure we take care of and put to use. So if we think of a computer as an intelligent agent or a humanoid robot, we might forget that there's a lot of special things that computers can do that people need to have done for them. Sophisticated algorithms, databases, superhuman sensors, information abundant displays, and powerful effectors. We'll take a look at these in a moment. And the third important principle for me was to support human creativity. People are passionate, empathic. They can show humility and intuition. These are good things for designers to have. They're very different from the attributes of computers, which may be powerful, fast, etc. But I see special things in people. People are different. I like people, and I want people to be empowered in all these ways, and I want to value those distinctive human capabilities. So the way I began to shape this was through about 20 versions of this diagram, and it may still be imperfect, but I see that the old language of intelligent agents and thinking machines, cognitive actors, is sort of fading. IBM advertised its IBM Watson, as a cognitive computing system. But 2 years ago, they removed that term. And a month ago, they had a garage sale of what remained of the Watson project, because that notion undermined the design of the right kinds of tools for physicians to make cancer decisions and diagnoses. This was these two serious failures at Memorial Sloan Kettering Hospital in New York and MD Anderson Clinic in Texas. And so those failures were really problematic. And I would say they were because the ambition was set in the wrong direction. So I prefer the language of super tools, maybe less cool, but it's the language I prefer to use that extend human abilities, that empower users, enhance, augment, amplify. So we'll take a look at some of these in a moment. Secondly, there's a lot of language about computers as teammates, collaborators, partners that will be working with us in a team. And I came to find a different way that I wanted to think about telebots, that teleoperated devices that were steerable or powerful prosthetics. Think of Iron Man, the comic and the movie of Tony Stark builds a device to support him, to make him more powerful. And my goal is to make superheroes and give everybody superpowers, which is what a digital camera does. It's what text messaging does, what many computer things do. The third was assured autonomy, the idea that the computers were independent, self-directed, and I wanted to see control centers that asserted human control and oversight. And the fourth was social robots. This idea, I think, also beginning to fade with the failure of Anki and Curie and Cosmo and Pepper and one after another, Ajibo. These devices and these companies, well-funded, didn't go anywhere. I mean, I think we should be watching the newer ideas of social robots that are emerging. Amazon's Astro is the current idea. It's a cute video, but I'm not sure there's a real purpose for this now $1,000 little Astro that follows you around or delivers a cup of coffee. I do think there are other ways. I call them active appliances, lower cost devices that are consumer oriented, and we'll take a look at these examples. So this gives you a layout. I should say I offer a compromising view that says maybe there's something to the stuff on the left side. And so there are ways in which you could be inspired by combined designs, which are this green surfboard in the middle of this diagram. This is the way I like to think about it. So the examples I've already mentioned, the super tools of digital cameras that give you enormous control over the picture you take before, during, and after, and they let you share easily your photos with friends and family. They're social tools, and they're super tools. They really do amazing things. I mean, 30 years ago, it was like 10% of the population could take a good picture with a camera. But now we get 90% of the population take pretty remarkable high quality pictures every day and share them with a lot of people. So that's the kind of empowerment transformation that I seek. Similarly, navigation devices here, plotting from the White House to the University of Maryland, College Park, just 8 miles away. And this is a good design of AI systems, which choose 3 routes here, including giving you predictive estimates of the time and where the congestions might be. And it's a wonderful blend of AI, machine learning algorithms, and good design. It gives you a preview. You click to start, you initiate the action, you follow along, but it's up to you. You can change. You can diverge from the planned route and go where you want to go and take the opportunity. If you see something that's interesting, you can stop and you can alter the path. Similarly, the successful strategies of machine learning embedded into text or search query auto-completion. I start typing University of Maryland and I get a bunch of suggestions that might be helpful, but it's up to me. I choose whether to use them or not. I'm in control. Lots of AI, lots of human control. Similarly, spelling corrections, I get recommendations, but it's up to me to decide if I want them or not. Here's a bigger super tool. And I think more people will have more devices like this. This is the Bloomberg terminal for financial traders and analysts around the world, and a large amount of information presented to them, driven by lots of machine learning. Bloomberg takes in 1.6 million text articles per day and filters them to find the 3 or 4 that are relevant to your needs and your decision-making, and presents them to you in ways that you can explore and then see the impact on other variables. So this kind of design of information abundant displays in a tiled, not overlapped display in a spatially stable way that enables traders to quickly look from one place to another and to manage the coordinated windows that are in this display. It's this kind of design that leads to 300,000 people around the world being willing to spend more than $20,000 a year to have this on their desk. So I think we'll see lots of versions of better control rooms. The active appliances are propagating, and designers are finding good ways to embed these in your household. The Google Nest thermostat was based on AI and machine learning techniques. And almost every device is now getting machine learning built into it in various forms of AI. The iRobot Roomba, which I own and use, it's imperfect, but it's getting better. The designs are being improved to give users control. And the very basic principles that I outline in the book, the previews, it does not give me a preview of where it's going. The cell phone app gives you a little better information, but I don't know when Roomba is going to come into my office so that I need to clear out in time. I don't know how long it's going to take. I don't know where it's going next. And those kind of things would improve devices like this. And similarly, the coffee makers and all these mundane appliances in your house of dishwashers and clothes dryers are increasingly have machine learning built into them to optimize for different conditions, sensors to tell if the clothing is dry or not, and what kind of clothing and how much clothing is in, so that it can optimize and save energy by speeding the process of drying your clothes. Very mundane, but this is the way progress is made. This is the widespread use of these technologies. The pacemaker, which I suggested earlier was an autonomous device, is becoming more user-controlled. You can operate it from your cell phone, and maybe more importantly, well, not equally importantly, Medtronic can monitor tens of thousands of pacemakers to improve the machine learning algorithms for different classes of users and different kinds of heart problems. And so it's that kind of combination of having some degree of autonomy, but also some degree of control that I see as the way of the future. You'll get a lively discussion if you talk about the Mars rovers. Are they an autonomous device on the surface of Mars? Well, they must be autonomous because they operate 200 million miles away and signals take 20 minutes to get there. Well, yes, they're autonomous in small ways. They can move and avoid obstacles. They can avoid precipices. They can turn their antenna to the right places automatically. They can point the solar panels in the optimal position automatically. Yet, there's a control room with 80 people that operates this device, that sets out the missions, that decides where to go, that takes advantage of opportunities that emerge, and avoids dangers and deals with repairs that inevitably come with these kind of devices. A telebot example that I like is this Da Vinci surgical system. Journalists love to have headline reports of robot surgeons better than human surgeons, but the manufacturer says robots don't perform surgery. Robots don't perform surgery. Your surgeon performs surgery with Da Vinci by using instruments that he or she guides via a console. So here we are again. There's a sort of love affair, infatuation with the idea of an autonomous robot, but the reality is you want people to be in control. And this device gives them opportunities to make very careful movements deep inside human cavities that would be very difficult to get to otherwise. It reduces the severity of the surgery by making smaller incisions and speeds patient recovery and improves outcomes. But it's the doctor, your surgeon, is doing the surgery. Control rooms, here a Hospital One manages the emergency room and other facilities, and here a counterterrorism center, people working together and with information abundant displays to make decisions on important issues. I mean, industrial control rooms, air traffic control, many other control rooms are growing and becoming an important part as we get much better sensors, more data, and the capacity to manage these kind of information systems. Okay, so let's move on in the remaining minutes to the governance structures. This is a complicated issue, and it raises us out of the technical side into the socio-technical side and the management and business questions of how we put AI and machine learning to work in modern systems. For me, I've laid the 15 recommendations out into these 4 ovals. I'll talk a little bit more about the ones here in what software engineering teams can do. I'll just here briefly mention that managers of companies that might have dozens of software engineering teams have to build a safety culture, a way in which the management hires and leads people to think that safety is number one. I guess my focus is more on life-critical and consequential applications. If errors happen in recommender systems and you get a strange recommendation of a movie or a restaurant, I'm not so troubled by that, but I am concerned about consequential legal, financial decisions and life-critical medical or transportation applications. And then the outer layer will be independent oversight. As much as these organizations can build a safety culture, it's extremely valuable to still have a layer of independent oversight in which outside, like insurance companies or auditing firms, can provide other information, guidance, and critiques of what companies can do. And that's the powerful counterbalancing force. Independent oversight. Independent oversight is what I advocate. And then government regulation can be a virtuous contribution. In the US, when government required car fuel efficiency and safety levels to be improved, it triggered a vast outpouring of innovation and great ideas that have led to more fuel efficient and more safe cars. In Europe, the GDPR regulations that ensured explainable AI triggered similarly tens of thousands of papers in the AI literature about how to do explainable. And that's what I want to talk about next in a few minutes here. There are 5 recommendations about software teams. I'll just mention briefly the idea of audit trails. We need a lot of research to decide how to make effective audit trails that would allow retrospective analysis of failures. Just as the airlines, civil aviation has become very safe because, in part, the flight data recorders that report what happens to aircraft. So when a crash occurs, the investigators have a pretty good record of what's happened. And it took 30 or 40 years to develop a proper flight data recorder to understand what was necessary to record. We're just at the beginning of that. And I'd like to encourage as a research theme, if you're looking for a PhD thesis, is what forms of audit trails are necessary to enable retrospective analyses of failures. You may not be able to capture every bit of data from a self-driving car, but the question is, what do you need to capture? And in the US, in the first Tesla autopilot crash that was deadly in 2016, one of the recommendations of the US National Transportation Safety Board was to have better audit trails. We need to know. We need to know how many crashes there were of Tesla cars operating on autopilot. You might want to visit a website called tesladeaths.com, tesladeaths.com, which last time I looked had a list of more than 230 deaths of Teslas with Tesla cars. Now, not all of them were caused by autopilot, all kinds of things. We don't know. We really don't know. So the idea of more transparency is important, and then the building of better audit trails. In my remaining minutes, I just want to give one example about explainable user interfaces, one of the other tasks for software engineers. And the usual discussion about it is to have retrospective explanations of failures. That is, the system provides a decision for a parole, a job hiring, a mortgage, and the user says, "What? Why was I rejected?" And there's a confusion and annoyance. And so the retrospective explanation will then go back and try to give an explanation. And about 90, I don't know, some high fraction, 98% of all the papers are about different forms of retrospective explanation. And I became increasingly concerned about that. And I think there's a better way to do this, which is to prevent the confusion and surprise that happens from these systems. And so I would prefer prospective user interfaces that are interactive, visual, and exploratory. Let me show you a small example. This is a post hoc or retrospective scenario where you've requested a mortgage. Again, a very simplified case with only three parameters. Mortgage amount requested $375,000, household monthly income $7,000, liquid assets $48,000. So that's your request. You submit, and you get a response, and it says, "We're sorry, your mortgage loan was not approved." And then it gives a guidance that is considered to be a pretty good example of a retrospective explanation. You might be approved if you reduce the mortgage amount requested, increase your household monthly income, or increase your liquid assets. Well, that's pretty good guidance, but you don't really know how much you need to increase or decrease these amounts. You don't know which one is the most influential and which one you should work hardest to change. So I propose this kind of an interface. Again, a very simplified one, but you get a slider for the amount requested. And if you reduce the amount requested, you'll get more blue, and your score will then rise closer to the goal, the score that you need. If you move the household monthly income to the right, you get more blue, you get a better score. If you move the liquid assets to the right, maybe you can borrow some money from family members and have higher liquid assets, and then you'll get a better score. And you can then explore and see which of these is the most influential on the outcome and helps you get to the score you need. And indeed, banks are beginning to implement variations of this idea. A sweet example of this is by some British librarians. I had a wonderful exchange with them, but they were making a recommender system for novels, and you could choose 4 sliders from funny to serious, in this case, from beautiful to disgusting, from no sexual content to explicit sexual, from optimistic to bleak. And as you move the sliders, the pictures of the covers change immediately. And so you have the immediate feedback to know why it happened. You don't have to ask, well, you know why, because you asked for a funnier kind of book. And so it's quite nicely done. It's a free service, but please send them a donation. They really deserve it. Or send them a thank you letter. I did. I sent them a donation too. And they gave me permission to use this figure. But it's a great example. And newspapers are also doing this, like sliders that say political, sports, or entertainment. And you move the sliders and you know why you got those recommendations. Okay, so that's the story here. And I'll just go to summarize the 3 points of this talk. One is to look at the idea of opening your mind to a 2-dimensional model of the Hci framework that you can have. If you break the design into the fine structure, you can have reliable, safe, and trustworthy systems where there's high levels of human control and high levels of automation. Okay, and then the shift in the way we think and the language we use to focus more on super tools, telebots, control centers, and active appliances. And the third is this rich structure of 15 recommendations about how to embed AI systems in the real world at scale, which is what the Delft Academic Fringe Festival is all about. That's what we want to do. We want to make successful systems that help people, that make lives better, that sustain the planet, that deal with climate change, that reduce misinformation, that make the world a better place. I'm pleased that my book, which just came out, last month, got a couple of nice starter reviews. It's one of the most important AI books in the last few years. Brian Clegg in the UK Popular Science, and just a couple of weeks ago, Forbes magazine, a major business magazine, said, excellent introduction, valuable to management who need to both understand how to better direct AI development and to acquire appropriate AI to solve market and social challenges. That was very pleasing to me to get that. And Virginia Dignam says, from Sweden, Umeå University, a tour de force into the increasingly important topic of human AI, a must read. So that's the book. And just the framework for the book is this complex diagram that at the apex, at the top says, our goal is to focus on human values, to increase human rights, support social justice and individual dignity. We want to make life better for people. This is not easy to do. Not all systems succeed, but that should be in our mind. And then we do this by thinking about the individual or community goals of self-efficacy, creativity, responsibility, social connections, add sustainability to that as well. And then the design aspirations I've laid out as reliable, safe, and trustworthy, organized into teams, organization, industry, and government. So that's rests on the foundation of the three parts of the book, the key ideas of the framework, the design metaphors we use, and the governance structures. Always, we need to remember the diverse stakeholders. There are about 25 that I enumerate in the book, but here I put about 5 down. Researchers get a lot of attention. We need to think about what they want to do as well. And developers, business leaders, policymakers, and the vast number of users or others we need to be paying attention to and include them in all our discussions. So we need to make this a more participatory process that brings together the stakeholders. And always we have to remember the threats, the malicious actors who would use it for oppressive purposes, for misinformation, for terrorism, for disrupting elections, for cybercrime. There are real threats. And I would say that we and others, myself included, underestimated how much the social media, which brought people from the margin a voice, gave them a voice, but we were unprepared for the degree of disruption that would occur. And we need to pay much more attention, and we need to push the social media platforms to really give that a high priority. It's really essential that we improve those features. Then the idea of bias is always a threat, and working to reduce bias in real world situations remains a substantial challenge, but I'm pleased to say the AI community has stepped forward and done a great deal here. Maybe worth calling out Joy Buolamwini at MIT, who worked on issues of bias and face recognition and produced within just 2 years dramatic changes in the algorithms that IBM, Amazon, and Microsoft were using. The film called Coded Bias is well worth watching, tells her story and the others who fought so well to counter some of the bias that occurs. or at least draw attention to it. And then the flawed software that can raise further problems. Okay, so that's the framework of the book. If you want to get involved, I do run a Google group. You can join here. Wednesday afternoons, I send out a short note once a week. And so you can comment back to me, and we get a lot of interesting commentary and discussion. So please join up and read some of the past notes that have been there. And then follow us on Twitter, Human Centered AI. We now have a Wikipedia page. Please read it, visit, tell your friends, and add to it. And then a website that has many more pointers to research groups around the world, to events, and so on. So there is a growing movement here, and I just remind you the future is human-centered. And I look forward to your questions and comments. Thank you for your time and attention.
Well, thank you so much, Ben. That was amazing. There was a lot of food for thought for all of us, and I'm sure everyone's equally excited to ask you a few things. But as we get people to start perhaps typing their questions in chat, you can also feel free to unmute yourselves, everyone. I can perhaps set the ball rolling, Ben, and ask you one of the questions that occurred to me while you went through. It was an amazing talk, lots of interesting ideas in there. I was wondering what your thoughts are about how you can use these design metaphors that you propose as a means to perhaps better orchestrate or allow people to rely appropriately on AI systems. Much in the spirit of what you captured, I believe, where the present day media and the general rhetoric has been to christen these AI systems as the silver bullet to all sorts of problems. Can the design metaphors that you suggest play a role in shaping appropriate trust and reliance on AI systems?
I hope so. I mean, I can point to examples where they do. My favorite example is the cell phone camera or the navigation devices, where we come to trust them pretty well. I mean, when the navigation device points you in the wrong direction, it's news, that someone got stranded or was led to a road that was washed out. And so it's having these as open, transparent systems where there's public commentary helps. I mean, that's one of the few principles I've come to accept, that openness and transparency, feedback, discussion is one of the ways we can make things better in the world. So I believe the new metaphors have a greater sense of humility on the part of the designer. The designer who sets out to make an intelligent agent and a social robot is often lured into the belief of perfectibility of technology, certainly the assured autonomy label. And I think that that is something we should change in our teaching, in our practice, and have a sense of humility about the devices we create, that they can be flawed. And therefore, when we know that, when we accept that, then we become more open to the idea of independent oversight, of transparency. Here's a nice example. Sean McGregor built a wonderful website called the AI Incident Database. It's part of the partnership of AI Incident Database. Look it up. And there are more than 1,000 reports of failures of AI systems. And this is designed to give designers an understanding of where the problems are. And this follows the traditions of existing fields, like the Food and Drug Administration in the US has an adverse drug event reporting system, whereby the public and clinicians and nurses and pharmacists can report the adverse effects of medications for certain patients. And that's how we learn. But if you don't have the feedback in place, you're not going to learn. So it's not just machine learning, it's human learning we want to talk about. And how do we take responsibility and get the feedback to make systems still better than they were before? That's the kind of message I'm talking about. Okay?
Thank you so much for that, Ben. I see that we have Frank van Hamelen from Vrije University who's got a question for you.
Yeah, thank you. So thank you very much for your talk. It's really much appreciated. My question is about also about the design metaphors that you proposed. I completely agree that the current AI metaphors are often overselling, but there seems to be very little space in your metaphors for initiative on the side of the system, or for proactive systems. Now you speak about powerful prosthetics or steerable instruments, which give a rather passive role. So do you see a tension between human-centeredness and proactiveness of these systems?
Yes, I do. I suggested that the right form of device gives a preview of what's going to happen. Okay, whether it's Roomba or a navigation device or an industrial robot. The preview is the essential thing. I mean, it's very nice. Brooks and Connor at University of Colorado show a very nice, set of studies where robots, industrial robots that give a visual preview of what they're going to do, enable the operators to perform much better. And I think it's sort of a basic principle, a preview first, and then you select which of the choices, you initiate the action, and then you manage the execution. It's a simple guideline, but it's a very powerful one. So your use of the word, the machine having initiative, or even Eric Horowitz's popular notion of mixed initiative, I still have trouble with. I'm a bit of a radical. I know I'm an extremist here, but think about it. I think what you want are more the idea of super tools that are in control of people, and therefore they're responsible. When a machine starts taking initiative, I get worried. I get worried, in this even simple ways. Netflix algorithms have shifted to be so it jumps up and starts showing me videos that I really don't want. And it's just, it's too pushing forward and annoying. So, I think we need to respect the needs of people to be in control. You want to bounce back on that, Frank?
Yeah, I think of course, I share your concerns about systems that have the wrong initiative or the undesirable initiative, but ruling it out, it seems to rather put a cap on the systems that we design. And I wonder if we should really be as strict on that as you propose.
Fair enough. I wouldn't say it puts a cap on them, but it makes the designers reflect a bit before, and they, the recommender systems, you could say they take initiative to make recommendations, but actually I'm requesting the recommendations. They're often in a spatially fixed position on the screen, and they don't take over and do it. They let me choose which of the alternatives. And so the initiative word is a little bit of a problem. I mean, should financial trading systems, should airline, cockpit systems give warnings to pilots? Yes. Okay. Should they take over control? I'd be much more careful. Yeah. I mean, you can imagine scenarios. I mean, would you buy a car which prevented you from going 20 miles above the speed limit? Or, or prevented you from starting the engine if your breath were analyzed to show a high level of alcohol. There's some virtues in those things, but we need to be careful about that and how we prevent the excesses that come to all of these. And so the word initiative is a little too open for me. I would rather say previews that suggest it's a preview for the user to decide.
Right. Thank you. Yeah.
Thank you.
Thanks, Ben. I think we have a related question. We have one of our most consistent attendees of the TAF events, Peter from the University of Pittsburgh. It's always lovely to see you here, Peter, and please go ahead.
Thanks. So then I have a question which is probably in your book, but I already received it last night, so didn't have a chance to read it. This is the question of how much control is good. I'm fully in support of control and been trying to get it in several fields for quite a while, but it turns out not every level of control is really working well. Specifically in the field of using AI in education, sometimes no control is actually really working at all, right? Just simple thing, push the button and you get what you want works. So we know that it's related to knowledge. The more knowledge about the domain you have, the more control you can do. But is it just the knowledge? What else? What else can tell you how much control the user can afford and manipulate?
Thank you, Peter. Good to see you. We've had many years of lively discussions on these issues. So I'm happy to continue. You focus on educational situations, I think is what you said.
Yeah, education is one of them, but we've also worked with recommender systems.
I think we might look instructively at the history of what's called intelligent tutoring systems, a notion that from my point of view has largely died out. Yes, there are some people still pursuing that, but the alternative that's been much more successful has been the MOOCs for one, and the idea of learning environments. Those are very different phrases and metaphors. The idea of intelligent tutor that gave you personalized training and there was a little avatar on the upper left side of the screen that told you what to do as a friendly teacher hasn't proven to be successful. And I don't think it will. Whereas learning environments that support creativity and exploration and discovery are, I think, much more the success story. And MOOCs are sort of a middle ground which provide personalized instruction, feedback, and guidance, and lots of AI going on, but it's pretty much your learning experience. I think the learning environments that support creativity are a good way to think about the way we want to support. Do you want to respond to that, Peter?
Well, I agree. So definitely MOOCs is a better example. Unfortunately, most of them has no AI. So it's actually the future generations which have to figure out how to get AI from ITS and freedom of navigation from MOOCs. Looking forward to it. Yeah.
Yeah,
Thanks.
I think that's right. Blending these things, integrating AI. I'm not sure I agree that MOOCs don't have AI generally. I mean, some of them work on strictly algorithmic approaches, but there's a lot of machine learning going on, or maybe it's just simple aggregated information that collects data over time about what tens of thousands of people might be doing. And there's two things they try to accomplish: improve the learning process, but improve the retention of participants. But people are concerned about the high dropout rates that people start with MOOCs, but they don't continue. So there's something we need to understand better about how to engage people in that way. Thank you. I see Klaus Atzenbach. I'm very pleased to see you here too. Thank you.
Thanks.
What's your question?
Yeah, thanks for the great talk, Ben. I have a question related to recommender systems. I'm doing some work in recommender systems and user interfaces, intelligent user interfaces, which people can use to create a context of what they are thinking and context of their ideas, and the system actually would respond to their thoughts. So it's the question is related to what you expect people to use, basically. So, for example, if we come up with a very great user interface, which enables people actually to put different thoughts and different ideas into a context, into associations. Do you think people would use such systems, or do you think people are used to today's recommender systems, just clicking the next item button and doing some binge watching on YouTube and Netflix? Or do you think we should kind of not force people, but present that work to people which is more complex, more towards and I have the hypertext community in mind. I have Doug Engelbart in mind with his idea of augmenting human intellect. Do you think this is too much for people?
I'm not sure I see the distinction you're making of what you think the newer idea would be to take. Are you suggesting that the hypertext or the recommender be more in control of the dialogue?
Let me give you an example. If you think about recommender systems, which we use for watching videos, for example, you don't have actually a good choice of creating different movies, different thoughts into a context. So basically what I need to do is I need to take some notebook to write down my ideas about movies I may want to watch and how movies actually would relate to each other and what I would like to watch next. Because the recommender system, which is presented to me in a web browser, for example, would only show me a list of items which I cannot restructure. Do you know what I mean?
Correct. Yes, I agree. I agree with that, that the current recommender systems often present a set of choices. Netflix tries to organize the choices into documentaries and dramas and so on. So there's some way, and it does allow you to keep a personal list of your of the ones you want. And there's a lot of machine learning trying to understand what I want, but I don't think it's been it's not as successful as you wish it would be, because I have different moods. Sometimes I want a thriller or an exciting crime drama or something, spy movie. And other times I want a really gentle, quiet, romantic story. And you can't figure out what I want right now. I mean, there's a growing movement that says trying to figure out what the human emotional state is a flawed and dangerous idea. That there's a guy named John Harrington who's been writing very thoughtfully about why emotion detection is not just, a poor technology, but dangerous. And so I'm more concerned, and there's a growing awareness that these attempts to understand your current emotional state are, we have to be really careful about that. People are much more interesting than Paul Ekman's 6 or 7 categories of emotions, and recognizing which category is a much more complicated process. So I would say, in response to your question about recommenders, I agree that giving users more control over what the recommendations look like and having an interactive process by which they can reshape the recommendations. I suggested the simple model of sliders, but you may have other ideas as well. And a better understanding of why certain recommendations were made would help. I'd like an open model that I could adjust or tweak. Or, I'd like to tonight set the thriller slider onto high, or onto low. I want to be able to control the model, not the model offering me something that it believes. You want to respond?
No, thanks for answering.
Okay, thank you. I see Ji Yang, one more hand, and I think we'll probably end it then.
Thanks, Ben. I do see, though, Martin also writes something in the chat, but I can go ahead first.
All right.
Thanks, Ben, for the amazing talk. I have a question that may be a little far-fetching, but I wonder what's your thoughts. So we often, in human-centered AI, we often wish to make AI systems reliable, but given the data-driven way of how AI is built today, and the fuzziness of what's there in the data, it might never be possible to create AI systems that are, for example, 99.99% accurate, like in many industry we have, right, as a requirement for the product that we build. So it might be fine in some domains like online shopping, right? But in some cases not. But regardless, these AI behaviors, if we are going to tolerate with their, let's say, misbehavior to a certain extent in the future, I wonder what's your thought about how that will shape people's behavior of people.
Thank you. Yes, and I see Martin Neef's question also. He says, would you advocate to refrain from such functionality? Well, 98% accuracy is okay for a recommender system, but not for a healthcare system or an aircraft system. So I would say shut it down. If it's not performing at the level of reliable, safe, and trustworthiness, shut it down. We have a long history. There are a lot of technologies that just don't work. And there's a lot of dangerous technologies, whether it's chemical pollution. We stopped using chlorofluorocarbons, okay, to stop the hole in the ozone layer. There are dangerous technologies. AI has some of them. AI has many virtuous technologies. Computing has many virtuous technologies, but there are real dangers, and we need to step up to understand the dangers and limit them. I've recently written a piece, maybe I'll take a minute here, that's called Blue Skies and Muddy Boots. Blue Skies and Muddy Boots. And the story of that is that when I read the AI literature, I increasingly became aware that there were two kind of families of discussions. The blue skies were all about the future and the wonderful things that were going to be, and the AGI and common sense and conscious and sentient robots that were doing wonderful things, or dystopian, terrible things that were going to happen. But it was theoretical, it was in the future, it was the world of potential. And the second school of writing is what I call the muddy boots. The people who pointed out the problems that existed, the things that were wrong, and they were doing it not just to be angry, but they saw the muddy boots, and muddy boots can be cleaned and they can be polished, they can be made good. And so I began to think of, every time I read an article about AI, is this a blue sky idea or is this a muddy boots? Okay. And interestingly enough, in the first pass of this, it turned out it was often, I'm going to get in trouble for this, but it was often the men who were writing the blue sky. Oh yes, there were exceptions. There were women too, but it was often men. And the muddy boots, I would say that movement began around 2016. There were earlier ones, but Cathy O'Neill's wonderful book, Weapons of Math Destruction, which pointed out the dangers of scale, opacity, and harm in systems. And then Kate Crawford and many others. But there are also researchers who looked at the muddy boots and said, I can clean this up with research, like Cynthia Rudin, who said, don't explain black boxes, just don't have black boxes. Okay. And she wins the $1 million prize from the AAAI for her improved models that were more understandable to people. And so, there's a lot of work. And again, there were men who participated in that as well. So I don't want to get into too much trouble here, but there was a sort of gender difference that I noticed. And of course, we need to be open to different points of view, non-binary, different racial and ethnic groups, indigenous voices. We need to listen to these different voices. And we have to make sure it's our responsibility as designers to prevent harm. Do no evil. It's the Hippocratic Oath, and we have to do that. And there are systems that are dangerous and are doing harm, and we can fix those. We can clean those muddy boots. And I think let's do it. So, onwards. There's a lot of work to be done, but there's room for everybody to do some of it. And I hope my talk influences you to shift your thinking and to work on some of the things that will make it more reliable, safe, and trustworthy. Some of the things that will support human self-efficacy, creativity, responsibility, sustainability, and social connectedness. That's where it goes. My little bumper sticker is here, the humans in the group, computers in the loop. People are social. Support social, support people working together and make it open. And have a little humility about what you can design into a machine. But, for me, I'll close and just say, if we do it right, the future is human-centered, and we can make a better world for ourselves, our children, and our grandchildren. Thank you again for the opportunity. Please contact me. Join the Google group. I think that's the best way to stay in touch on a weekly basis. And I wish you well. And thanks once again for that extremely inspiring talk. It was a pleasure to host you over here. And
it was great to see you engage with all of our audience over here as well. Thank you so much. Have a nice day. And thanks everyone for joining. Do join us at the next Academic Fringe Festival event. We have a nice array of speakers coming up, but thanks once again, Ben. Brilliant talk. Thanks for joining us.
Great, thank you.